This is for Year 12 methods. It comes out of the Functions Test SAC for 2014, question number 12. Evaluate this when theta equals 0. So if that's 0, got minus 6 cos pi on 3 minus 3. Cos of pi on 3 is in the first quadrant, so that's going to equal a half. Negative 6 times a half minus 3 equals negative 3 minus 3 equals negative 6. Now, reading the question, that's the same rule as that rule, which is the same rule as this rule. And over the page, I'm asked to graph it. So this is my y-intercept, or when I do draw my graph. Okay, find the solutions to this. This is the same rule. If I'm setting it equal to 0, that's going to find the x-intercepts when I find them. Okay, so I need to rearrange this so that I just have the cosine. So negative 6 cos 2 theta plus pi on 3 equals 3. Cos of 2 theta plus pi on 3 equals a half. Negative a half. Therefore, all stations to Collingwood, these two quadrants are where I'm looking. So 2 theta plus pi on 3 is going to equal pi minus pi on 3, since I'm going to be in this quadrant and my table tells me pi on 3 is the value. Then I'm going to have pi plus pi on 3, and because I need to go to negative pi going backwards, it's going to be minus pi plus pi on 3 and minus pi on 3. So 2 theta plus pi on 3 equals 2 pi on 3, 4 pi on 3, minus 2 pi on 3, and minus 4 pi on 3. Moving the pi on 3 over, 2 theta equals 2 pi on 3 pi on 3. 4 pi on 3 minus pi on 3 is pi. Minus 2 minus pi is minus pi. And minus 4 minus another pi is minus 5 pi on 3, which means theta equals pi on 6, pi on 2, minus pi on 2, and minus 5 pi on 6. And they're going to be my answers. Find the general solution is the next question. Find the general solution. Well, I know from the previous question that I have answers here and here, and those answers are pi minus pi on 3 and pi plus pi on 3. And I also have 3 pi minus pi on 3 and 3 pi plus pi on 3. And that will continue till I have 5 pi, 7 pi. Therefore, 2 theta plus pi on 3 equals all the odd pi's minus pi on 3, or the odd pi's plus pi on 3. So that's 2n plus 1 pi, that's how I can get odd numbers, minus pi on 3, or 2n plus 1 pi plus pi on 3. If I move my pi on 3 over, then 2 theta equals 2n plus 1 pi minus 2 pi on 3, or 2n plus 1 pi, and then if I divide by 2, theta equals 2n plus 1 pi on 2 minus pi on 3, or 2n plus 1 on 2 pi. And that's one set of general rules. There are plenty of other general rules as well. Get your graph. Well, I know from the previous question that my y-intercept equals negative 6 and that my x-intercepts equal pi on 6, pi on 2, minus pi on 2, minus 5 pi on 6. So I know that already. I know that the period equals 2 pi divided by 2, because that's my value of n. That's going to be pi. I know that my median is going to be negative 3. I know my amplitude will equal 6. Therefore my maximum will equal negative 3 plus 6, 3. My minimum will equal negative 9. And isolating in here, I'm going to have minus 6 cos 2 theta plus pi on 6 minus 3. And I need to draw it from minus pi to pi. Okay, I know I'd like to draw minus 6 cos. I'd like to draw minus 6 cos of 2 theta. And once I've drawn that, I would then like to move them to the left, pi on 6, and down 3. So let's draw this first. So there's 6, and I'll put in a dotted line to show where the 6 is. There's minus 6, and I'll put in the dotted line to show where the minus 6 is. I know that we're going to go across to pi, and I know we're going to go across to minus pi, and half of that, half of that. Now, because I'm going to have moving pi on 6s, I'd like to divide my axis into 12ths. So if that's pi on 2, and that's minus pi on 2, if I divide these into thirds and thirds, that will be pi on 6, 2 pi on 6, 3 pi. They're all pi on 6 thirds, they're all pi on 6s. And if I halve them again, that's going to give me pi on 12. Okay, so what do I know? I know I've got a negative cos, so it's going to start down here and finish down here because the period is pi. It's going to be there, and it's going to be dead middle and dead middle, and it's going to look like that. It's going to look like that, and it's going to finish there, and it's going to be dead middle at pi on 2 up there, and halfway, and we're going to look like that. That's what that looks like. I now need to move everything pi on 6 to the left and down 3. So I might put in a little guiding mark of 3 and a guiding mark for negative 9 and a guiding mark for negative 3. Okay, so everything's going to move to the left, pi on 6, so we're going to go across 2, down 3, over 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 2, 2, down 3, over 2, down 3, over 2, down 3, over 2, down 3, to give me a line that looks like okay, so I've moved it across. Now, I do know that my x-intercepts are these values, and lo and behold, that's negative 5 pi on 6, that's negative pi on 2, that's pi on 6, and that's pi on 2. I've gone through the x-axis exactly where they were. I know my y-intercept is negative 6, and I've gone through it negative 6. I also know that I need to draw it from minus pi to pi. So I know that that's also going to be at negative 6, pi and negative 6, and I need to stop this here at minus pi negative 6. So now I'm ready to be able to sketch my final copy, which will be the red copy. Pi minus pi, the guiding mark for negative 3, negative 6, negative 9, and 3. And I need to know that that is pi on 2, that's negative pi on 2, that will be pi on 6, that will be 5 pi. I'm going to start my graph at negative pi and 6, and then I'm going to go up through there, through the top to there, and then I'm going to come down to here and get back to negative 6. And then I'm going to go up through there, go to there, go down to here and get back to negative. So pi and negative 6 minus pi and negative 6. Negative 6 is my y-intercept, minus 5 pi on 6, minus pi on 2, pi on 6, pi on 2, endpoints shown, and that's my graph.